Alright, so this is the third video of our differentiation video series, and in this one we're going to be looking at the product rule. In the previous video we looked at the chain rule, right? And the chain rule we know we use it when we have to differentiate a composite function. Well, for the product rule, we use it when we are multiplying two functions together. Okay? So whenever you see two different functions and they're multiplied together, then if we were to differentiate it, then we have to use the product rule. So the product rule is given here in this notation here. And there's two ways of giving it, but I prefer to use it as y is u times v. So as I said, there's two functions, so you call one of them u, one of them v. Once you do that, then you differentiate each one separately, and then you multiply them together. So I think it's best by going for an example. So let's say we have an equation y is equal to x squared times sine x. Right, so we have two functions, right? We have the x squared function and with the sine x function, and then multiply together, so we know we should use the chain rule, so the product rule. So, as we said, we set one of them as equal to u, so I'm going to set x squared as u, and one of them is equal to v, so sine x is equal to v. For the product rule, it doesn't matter which one you set as u and v, whereas the quotient rule, which we'll look at later on, it does matter which one you set as u and v. So once you've done this, then we have to differentiate each one separately. So I'm going to just write it as u prime. So differentiating x squared, I get 2x. And then v prime, differentiating sine x, I get cos x like this. Now once we've done this, all we have to do is now we have to cross multiply. So multiply like this. So our derivative dy by dx is equal to u times v prime. So it's going to be x squared cos x plus v times u prime, so 2x sine x. Once again, it doesn't matter which one you pop in the first position or the second position, it's just for the product rule, it does not really matter at all. And that's it, that's how you differentiate a function with the product rule. Right, let's see another example. So let's say I want to differentiate y is equal to e to the 4x times by ln x squared plus 1. In the previous videos, we learned how to differentiate exponential logs and natural logs, right? So we can do this as well. So once again, we set our u and v. So it doesn't, as I said, it doesn't matter which one you set as u. So in this case, I'm going to set e to the 4x as u, and v will be equal to ln x squared plus 1. And now all we need to do is differentiate each one separately. So differentiating e to the 4x is 4e to the 4x. And differentiating ln x squared, we know when we differentiate ln terms, it's always a fraction with x squared plus 1 in the denominator, and then we differentiate that as well, so it's 2x on the numerator. And as we said now, all we have to do is just multiply like cross like this. So our dy by dx is equal to 2x e to the 4x over x squared plus 1, so that's our u times v prime, plus v times u prime would be 4e to the 4x ln x squared plus 1. So as long as you clearly state where u and v are, then you can pretty much differentiate anything you want if we have to use the product rule. So let's just try one more example. So let's say I want to differentiate y is equal to 3x multiplied by 4x plus 1 to the power of a half, like this. So once again, this is technically two functions multiplied together, so we use the product rule. So we set our u and v, so u I'm going to call as 3x, v I'm going to call as 4x plus 1 to the power of a half. And u prime is just 3. For v prime, as you see, we have a power, right? And we know from previous videos that if we have a power, then we can use a chain rule. So this example is actually using a chain rule inside a product rule. But the same technique goes. So using the chain rule, we have the power comes down, half, multiply the derivative of the bracket, so it's 4, rewrite the whole bracket out again, and minus 1 to the power, so you get minus a half. And so therefore, our dy by dx is going to be u times v prime, so 3 times 4 divided by 2 is 6x, 4x plus 1 to the power of negative a half, plus 3 times 4x plus 1 to the power of a half. So as it doesn't matter if the function is a bit more difficult, as long as you differentiate each separate one respectively, then we can use the product rule in all cases. So that's the product rule, and the final rule we're going to learn is the quotient rule, which will be in the next video.